dear students, today let us see about the next concept. In the last class, we have studied about the important aspects of the electrical field. Today, let us study about an expression for the electrical field. For the electrical field at a point due to multiple charges or due to system of charges. Due to multiple charges or due to system of charges. See, while you are studying the forces also, we have calculated total force or electrical force at a point due to multiple charges or due to system of charges. What we are generally calling it out as superposition principle. Here also we are going to use superposition principle to get the net or the total electrical field at a point due to the point charges. So superposition principle gives us the net electrical field at a point, due to multiple charges or due to system of charges. See, let us take like this. I am having innumerable number of charges like this: Q1, Q2, Q3, Q4, etc. up to Qn. Let us take a point P here. From Q1 to P, I can consider the distance as R12 or I can write it out as R1P. Then from Q2 to P, I can write R2P. From Q3 to P, R3P. Q4 to P, R4P. From Qn to P, I can write it out as Rnp. So at this point, what is the total electrical field E? You see, due to E1 or due to Q1, electrical field is E1. Due to Q2, electrical field is E2. Due to Q3, electrical field is E3. Due to Q4, electrical field is E4. Due to Qn, electrical field is En. If all these charges are considered to be positive in nature, then this electrical field will be acting away from what? Away from this charge. E1, E2, E3 and everything is acting away from this charge. Now, what is the total electrical field available at this point? So, total electrical field R, I can write it out as net electrical field. The total electrical field or net electrical field, I am writing it out as NE net. In what direction this is available? Again, given by the definition, total electrical field, that is net electrical field, E vector is equal to vector sum of, according to the superposition principle, it is equal to vector sum of individual forces. Vector sum of individual electrical fields, not forces, individual electrical fields. So E net is equal to vector sum of individual electrical fields. How I can write? See, for each and every charge, I am writing the electrical field. So E1 vector is equal to the constant K into Q1 divided by R1P the whole square into R1P cap, acting away from the charge. Similarly, if I am writing E2 vector, again I can state K into Q2 divided by R2P the whole square into R2P cap, Similarly, E3 vector is equal to K into Q1 divided by R3P square into R3P cap. So, if I am going on like this, I can write it out as what? This is E3. I can write it out as En. What is the value of En vector? En vector equal to K into, it is considered to be Qn by R n1 square into R n1 cap. All are acting in the same direction since all the charges are considered to be positive in nature. Therefore, net electrical field E net vector is equal to, I can write like this, E1 vector plus E2 vector plus E3 vector plus E4 vector plus etc. up to En vector. So I can substitute E net is equal to E1 is K into Q1 divided by R1P square into R1P cap plus then E2 K into Q2 divided by R2P square into R2P cap plus etc. En is K into Qn divided by Rnp square into Rnp cap. I can take K as a common factor. See, if I am taking K as common, then I can write like this. See, E net vector is equal to, take K as a common factor, Q1 divided by R1P square into R1P cap plus Q2 divided by R2P into R2P cap plus Q3 divided by R3P square, here also square, into R3P cap plus etc. up to Qn divided by Rnp square into Rnp cap. Now, let us again, instead of K, you can substitute 1 by 4 pi epsilon 0 into the same thing, Q1 by R1P square into R1P cap plus Q2 divided by R2P square into R2P cap plus Q3 divided by R3P square into R3P cap plus etc. up to Qn divided by Rnp square into Rnp cap. This is called to be expression for E net or net electrical field. See, this equation can also be written mathematically using sigma. See, also you can write this as also E vector net equal to 1 divided by 4 pi epsilon 0 into, we can write all these terms in case of or using sigma of, see, Q of I divided by Ri of P the whole square multiplied it with Rip cap. What is this I? The value of I ranging from 1 to n. So instead of I, you are substituting 1, Q1 divided by R1P square into R1P. Then since it is summation plus, instead of I, you substitute 2 and so on. So in what direction it acts? Always acting away from the charge, since the charge is positive. What about its SI unit? when I am considering its SI unit, it is Newton per Coulomb, N C power minus 1. So, with this, the concept over. See, regarding this, you are having only one statement, only one point. Look at the cursor. See, I have written it here. The total electrical field available E net, or the net electrical field available E net, is equal to, it is equal to the vector sum of individual electrical fields. Based on this concept alone, we have written this equation. E net is equal to E1 plus E1 vector plus E2 vector plus E3 vector plus E4 vector, etc. up to En vector. I think are very clear regarding this. So with this, the second term or second part of this lesson 1 called to be electrostatics. The second part is electrical field. So regarding this electrical field over, and we have to see the problems regarding electrical field also, that we shall do it in our next video. Thank you. All the best.